Hi everyone, I'm Miss Koenig and this is a quick video tutorial on solving algebraic equations. Let's jump in. Let's jump into this first equation. Now what you see here is a relatively typical equation that you would solve. It's got kind of a two-step process for solving. It's important to recognize with an equation that you've got two sides that are supposed to be equal. So this equal sign is really an important aspect in an equation, not only because the word equation means you've got two things that are equal, but also because it balances the left and the right side. In order to solve it, sometimes helps when you first start out to add a line down the equal side. And it reminds you that the left side and the right side are the same, and that whatever you do on the left side has to happen on the right side in order for them to stay equal. Now the first goal is to find the term with the variable and get it by itself. We say isolate the term with the variable. So here's my term with a variable, and in order to get it isolated, I need the plus 5 to be gone. Now you remove something from an equation or you move it to the other side or however you verbalize what's going on. The way you get that negative 3x isolated is by using an opposite operation. So I see that I have a plus 5. The opposite of that would be to subtract 5. In equation solving, if you subtract 5 from the left side, you have to subtract 5 from the right side also. That's what keeps your equation equal. That's what balances the scale. So that's what that line kind of helps us to do, the one that's down the equal sign. Now, the reason why that works is because 5 minus 5 is 0, resulting in my negative 3x being the only thing left on the left side of my equation. On the right side, I end up with 12. From here, it's a one-step equation like you've most likely seen in a prior course. And this one-step equation is telling me that negative 3 times something is 12. Again, we want to use opposite operations. If the negative 3 is being multiplied by the x, the opposite operation would be to divide the negative 3. Now, the reason why that works is not because negative 3 divided by negative 3 is equal to 0. In this case, negative 3 divided by negative 3 is 1. So this results with 1x, or just x, which is exactly what we're looking for when we solve. On the right-hand side, I end up with 12 over negative 3, which means 12 divided by negative 3, and that's negative 4. Now remember that you can check your work on any equation that you solve by plugging your variable back in. So I'm going to take this value, and I'm going to put it in for x, and I'll see if I get 17. If I do, that means I've done it right. So negative 3 times negative 4, that's where I plugged it in, plus 5. Negative 3 times negative 4 is positive 12, and 12 plus 5 is 17. Because that matches this value, that tells me that I've done it right, and x does in fact equal negative 4. Let's try another. Now this equation looks a little bit different, but it's essentially the same process. Again, I'm going to draw the line down my equal sign. Your goal will be to work toward not needing that line. However, if it helps you, if you're just starting out, use it. It helps remind you that you should do something on the left side and the same identical thing on the right side as you solve. So the term with the variable in this case is this 5x, which means I need to get rid of the 2. Now the 2 doesn't have a sign in front of it, which should be your indication that it's a positive 2. So we'll actually use the fact that it's a positive as its sign. The opposite of a positive would be a negative, so we will be subtracting or using a negative 2 from both sides in order to remove the 2. Now again, remember that when I subtract 2, that results in a 0, which is kind of what I'm shooting for along that process. The 2 minus 2 is 0, which leaves me with just my term with a variable. Now when I bring down the 5x, I'm also going to bring down the minus, and we will now think of it as a negative 5x. So make sure that if you see a minus, when you bring it down, it needs to show up in the next step again. It's really kind of a common mistake for those minuses and negatives to disappear in equation solving, and that's when you've made an error. On the right-hand side, 32 minus 2 is 30. Now again, when I solve, I want to get that negative 5 out of there. I want to result with a 1x. So I'll divide by negative 5 on both sides. Negative 5 divided by negative 5 again gives me 1. So 1x, or just x, is equal to 30 divided by negative 5 is negative 6. So let's check our answer. Here I have 2 minus 5, and then I have a negative 6. And I'm trying to see if I get 32. If I do, I've done it correctly. Now this has a lot of negatives floating around in it, so I would really tune into your order of operations here and solve that inside first. 5 times negative 6 will give you negative 30. And then when you do 2 minus negative 30, remember that that can be rewritten to plus 30, which gives you 32. And because that's the same as the answer up here, that means my answer of x equal to negative 6 is correct. Let's try another. This equation looks just a little bit different than the two that we've seen previously. It's good to see a wide variety of equations. That way you know how to approach just about anything you see. So first thing I'm going to do is draw a line down my equal sign just like I've done in previous examples. And the term that I'm trying to isolate is the one with a variable. In this case, it's x over 3. Now, in order to isolate that, I need to remove the plus 6, and I do that with the opposite operation. So I subtract 6 from both sides. That leaves me, as you know, with a 0 here. And thus, I can bring down my x over 3 and set it equal to 14 minus 6, which is 8. Now this looks a little bit different, but let's think about what x over 3 means. What that means is that x is being divided by 3, and the opposite of dividing by 3 is multiplying by 3 on both sides. Now, here's what's happening when we do that. Some students would look at me and they would say, what in the world? How does that result in a 1? So 3 times x over 3 can be rewritten 3 over 1 times x over 3, which would give you 3x over 3. Now, just like before, 3 divided by 3 gives you 1, which leaves me with 1x, or just x. So although this example looks a little different, it looks a little unusual, when we multiply by 3 on both sides, what we have done essentially is gotten ourselves to a 1x. And then on the right side, 8 times 3 is 24. Now, just like before, I'm going to check this answer. I'll plug in my 24. This time, what it looks like is 24 over 3 plus 6. And I'm hoping to find that this equals 14. If it does, then I've done it correctly. If it equals anything that's not 14, then I've done it incorrectly. So 24 over 3 is the same as 24 divided by 3, which in this case is 8. And 8 plus 6 equals 14. So that tells me I've solved correctly, and x does equal 24. Let's try another. Now here I have a different kind of equation, and this one has distributing. So if you're not familiar with distributing, that's another, that's kind of a prerequisite skill. So you should review that before watching this example. However, if you are familiar, stick with me. Let's give it a try. Now here I have a 2 outside the parentheses. Anytime you have something outside parentheses, you should distribute it to everything inside the parentheses. So 2 times x would give you 2x. 2 times 4 would give you 8. And then I want to bring down my negative 12. Be extra careful that when you're bringing stuff down, you bring along all the negatives, all the positives, all the signs, just so nothing gets lost. From here, you're solving just like you would solve any other equation. So I want to isolate the term with a variable, which means I need to add 8 to both sides. That gives me negative 4. And when I divide by 2, I end up with x equal to negative 2. You'll notice I have here the exact same example we saw a minute ago. We know what the answer is. We already know one way we could solve, but I want to show you another way you can solve a problem with distributing. So there are kind of 2 ways you can approach this problem. Neither is better or worse or more accurate. So it's just good to be familiar with different things you can do to manipulate an equation. Now, 2 is being multiplied by x minus 4. A different way to approach this problem would be to remove the 2 from the left side altogether. Remove it from the term with the variable. And how do we remove it? We do so with an opposite operation. The opposite of multiplying by 2 is dividing by 2. So I can divide by 2 on both sides. The reason why I'm allowed to do that is because this top part of my equation essentially says I have 2 groups of x minus 4. If I divide by 2, I now have 1 group of x minus 4. On the right side, that leaves me with negative 12 divided by 2, which is negative 6. From here, I've got a one-step equation, but it looks a little different than some of them we've seen before. We don't actually have to divide or multiply by anything at this point. I'm trying to isolate my variable. I need to remove the minus 4, and therefore I'd use the opposite operation, which is to add 4 on both sides. And that leaves me with x equal to -2. Again, it's the same answer we've gotten before, so if you like the process of distributing and that feels familiar to you, feel free to continue that practice when you're solving, but I did want you to see another way you could approach this problem. All right, this is the last example I have for you today. I wanted you to see this example because not every equation is given to you in the most simplified form. Sometimes there's some simplifying you need to do along the way prior to solving. Now you'll notice on the left side of my equal sign, this time I have 3 terms. The terms are the things that are separated by the minus sign, so term 1, term 2, term 3, and 2 of those terms would be considered like terms. So when you're solving, sometimes it helps to simplify the like terms first. I can only do that as long as they're on the same side of the equal sign, so that's important to identify. These are both on the left side, which means I can combine like terms and simplify the left side before I solve. In this case, 2x minus 3x is -1x. I'll bring down my -9, and I'll bring down my 11. From here, I'm solving in the same way I would have before. I need to isolate the term with a variable, which means I will need to add 9 to both sides, resulting in a 20 on the right side. On the left side, -9 plus 9 gives me 0, so all that's left is my -1x. Now, I don't want -1x. We've talked a lot about 1x. What we're looking for when we solve is a positive 1x. So I'll treat that like any other number and I'll divide by it on both sides. -1 divided by -1 is 1, leaving me with 1x, or just x. And on the right side, 20 divided by -1 is 20. So I hope these examples give you a better idea of how to approach some problem solving when you've got a 2-step or a multi-step equation. Sometimes you can get right into solving. You can isolate the term with a variable. You can use your opposite operations. At other times, you might have to distribute or simplify first. Again, I hope this helps in your problem solving. Thanks for being here. Have a great day, and I'll see you next time.